Welcome to this inLab Software 15 tutorial. In this video, you will learn how to scan the upper jaw to move it into the partial framework software. Moreover, the design of model casts for the upper and lower jaw will be demonstrated. First, open your inLab Software 15 and enter a case. There is no need to enter any kind of restoration. You can go directly into the scan mode. After the scanner has been activated, you now have the possibility to choose between the scanning option Capture Area or the Reduced Scanning mode. In this case, the Capture Area mode has been chosen. Take note that it is also important to check and see if under the model option Complete, Model Calculation is selected. Now begin with the scanning process. You can highlight the critical areas on the model, which in this case would be where the clasps are going to be placed. Next, click on Apply and the scanning process will proceed. After all the scanning is completed, the Continue button appears. At this stage, check all relevant areas on the model if they have been scanned to your full satisfaction, and if necessary, add additional images. In this case, place the model in a position where the additional scan is visible on the screen. With a double click, the scanner goes into position and rescans the chosen area. When you are satisfied with the model, move on by clicking the Continue tab and the model will be calculated. The model now has been calculated, and now you may decide if you want to determine the model axis here in the inLab Software 15 or to do this step in the partial framework software. In this case, it was decided to set the model axis here in the inLab 15 software. Set the values. When you are done with this, move up to the top of the Windows bar and go to the application icon in which the partial framework software is found. Now, send this model to the partial framework software. The software has opened and at the same time has imported your model. Now you can reset the model axis if desired. Go to the Blockout axis step. You have the option to set the angle for the blocking out of the model's undercuts and, by moving this arrow, determine the degrees of undercuts and angulation. Here, the measurement of the undercuts is demonstrated by this color code. Take a look at this and see where you want to place the clasps. Here you can go a little back and forth in this corner. I think we now have this case ideally, and that we can now continue on the blocking out of the model. Click here on OK, and the undercuts of the model will now automatically be blocked out. The blocked out areas are marked in blue. You now can, with the help of the right mouse button, or over here in our Tools menu, choose the Form tool. With the Smooth option, you can switch between plus and minus by pushing the spacebar on the keyboard. Now, remove the area in which you want to place the clasp tip, which should be below the equator of the tooth. This is done easily by choosing the left mouse button to determine the size of the area that is to be edited. This is visualized by the yellow circle. The size can also be determined by moving this slide bar. At the same time, you can change to Form Plus and wax out the areas where the clasp connectors will be placed. Take these steps in order to prepare your model for the design. On the other side of the model, you can also remove the virtual wax for the clasp tips where they are going to be placed. With the help of the Kerr margin liner, you can draw on the model prior to scanning where the base plate or the clasps are to be placed. The Kerr margin liner is available in blue and in red. Red is suitable for the lighter modes and blue is more suitable for the darker models. In order to show you the markings on the model, we have to go back to inLab 15. The rear area of the base plate and a clasp have already been drawn on the model. These markings are not very visible at this stage, but highly visible when changing to the intensity mode in the partial framework software. You can purchase the Kerr margin liner pen through your distributor. Back in the partial framework software, you can vividly see the markings under the intensive image. You can now precisely place your base plate or clasps exactly where they were initially planned. The model preparation is now completed. You can now move on to the design phase. There are many different tools at your disposal. For example, the retention fragments, in which you determine the space to the soft tissue. Different clasp types, such as for molars, premolars, or ring forms. The base plates, the sublingual bar, the connectors to the clasps, and also the occlusal rest. First, mark the area where the retention grids are to be. The sequence in which element you first choose is irrelevant. You can place them in any order you desire. This is easily drawn where the retention grid is to be placed. Here you can choose if the retentions should be round or square-shaped. In this case, it was decided to use the rounded holes. At the same time, every line is editable by dragging or by redrawing the lines under Edit. This is applicable throughout the software. After setting the retentions, now continue with the clasps. Move on and choose a premolar size clasp. The clasp always starts at the clasp tip and ends in the middle. If you have made a mistake and started on the wrong end, click on Flip Direction to make the correction. Also here you can drag the line or redraw it by choosing Edit Line. To add an additional clasp, click on Add. Add an additional clasp as shown before. When the clasp has been positioned, set the clasp connector. Also here you can edit it as you wish. Here you can add a rest. This rest can of course also be edited. You can change the size and thickness. At the same time, you can also place retention pins on the grid. These are easily placed by single clicks. If one is to be edited, activate one to tilt it or to move it in any direction. You could also reduce the height of the pin by using the Height slide bar. Working along, you'll now enter the baseplate. You can construct different baseplate forms, as you may adjust the form of the holes in the plate. Of course, it is much easier to mark the baseplate if it is drawn on the model. Also here, you can edit the plate to your own desires. This is the finishing line of the case, where the acrylic ends later in the restoration. In this step, all elements are constructed. In the finalizing step, all data of the elements are collected here and fitted together. Before coming to this step, the design of a palate-free area on the maxillary baseplate, as well as the design of a sublingual bar for a denture in the lower jaw, will be demonstrated. To design a palate-free baseplate, we first enter the complete size of the base. This is done quite easily because the model has been adapted to include a border seal on the baseplate. Enter the line piece by piece. Then, let the software compute a complete baseplate. You could edit the base if you want. This is possible at any time to change and improve your design. Now, go to Add Baseplate and under the Display option, deactivate the existing baseplate. Now you have the ability to enter the next baseplate. With a double-click, close the line. Now, both plates are calculated to a palate-free baseplate. This, of course, we can also edit on the outside and on the inside line. Let us move on to a sublingual bar. In order to design a sublingual bar, we click on the corresponding icon. Remember, we just draw the middle line of the lingual bar. When this is done, the lingual bar is then calculated. You can edit these lines. As here, you can shape a raise for the clasp connector, therefore making the bar in a more functional form. The thickness of the lingual bar can also be recalculated if necessary. This can be done at any time, and you can thus design an individual partial framework in In addition, the overall thickness of the clasp can be adjusted by holding the left mouse button and confirmed by a double click. As you can see, the software has many features for reworking. Now we come to the last step, finalization. In this step, all designed elements are first calculated and can then be finalized. You can now use the following tools. You can use the Form tool, you can apply material, and you can add a support bar. Begin with applying material with the Form tool. This can be done with Form Plus. Click to place material points at the respective locations to reinforce the material. Use the Smooth tool to integrate the material into your design. You can also measure the thickness at any time. The scale at the right shows the thicknesses by color. This allows you to easily check the thickness of the material in the model. Finally, a support bar can be inserted. This can also be done at the tips of the clasps. The thickness of these bars can be adjusted by pressing and holding the right mouse button. This is especially useful if you want to mill or print the design. Finally, you can hide the jaw in order to assess the finished model cast. As a last step, you export the design in STL format with the selected file name in order to send it to a CAM software in your production unit. Thank you for watching. We wish you lots of success working with the inLab Software 15.